All right. If you can, that will be only. Yeah, I've already for the portal. I'm still retrieving the portal. I was marking other assignments which some of you submitted by hand because you are desk students, weekend students, online students. So I think what I will do is there are other students who submitted their assignments physically, papers, they wrote on papers. So which question? No, this one I'm not saying you have to put it on portal. All right. But the one I'll put on portal an assignment. But this one I'm saying it just because you have failed the paper. I want you to do the paper. All right? Okay. BPS 10123. BP BPS 01823. BPS 00523. BPS 00123. BPS 02924. BPS 03224. You have to take again the question paper. If you don't have the question paper, please you get your question paper. You have to take the question paper. That is yours. BPS 02324. All right. BPS 00323. It's not your paper. Yeah, but I'm reading it here. BPS 015/23. BHR 00823. Oh, that's question paper? No, that question paper is here. I think I'll give you the question paper, don't worry. 23? Question paper, is this not your question paper? Take this one. That maybe this is your question paper? Okay. You you have to take together with your question paper. Eh? BPS 044/24. BPS 034/24. BPS 004/23. BPS 022/23. This one? Yeah, just take that one first. BPS 027/23. BPS 022/23. This one?
Yeah.
Okay. BPS 033/23. Yeah, I will give you. Don't worry. BPS 033/23. BPS 040/24. BPS 036/23. BPS 028/24. No, I'll give you the paper, don't worry. Your question paper, is this not your question paper? This one. Take this one. Anyone who has not received the question paper, you can come get the question paper. Question paper, come get the question paper here. If you don't have a question paper, come get a question paper. No, I'm still. If you don't have a question paper. No, I will. Don't worry. Don't worry. BPS stroke 032 stroke 23. BPS stroke 027 stroke 23. BPS stroke 027. Hey, yako nina stroke jana. Ndio ulibizi soko yangu. BRM stroke 015 stroke 24. Okay. Yes? What? BMK. Huh? 001. Hey. Then you are saying yours is what? BMK what? BMK. BMK. BMK 003 stroke 23. So I'm saying just because we have to get you this one. Take it this one. I'm giving you the paper. Don't worry. Oh no, I'm giving you this one. I'm branding you one. Because I'm saying you have to write that again. The MEC, I want you. Is this your paper? No, I'm saying let's find. Oh yeah. All right. What I'm saying is, see, we are here to learn. All right. So I'm urging you. I know you have performed badly, so I'm urging you. This I'm taking this. Professor, I need to. We are taking this one as an assignment. I'm giving you that one as an assignment. Right? Clear? I'm giving you that as an assignment. Can you? That assignment. There are two people who have done well. I think you can refer. You can refer to them, but you have to come up with an assignment. So we need to have. There are two. This one you can help your friends. That one you can help your friends. One, two. So I think what to do is do it as an assignment, and I'll grade that one. I'll grade that one. Those of you, all of you who have failed, except those maybe those whatsoever, but the rest I will regrade that again. Can you do that as an assignment? Right? Is that right? Because I am here behind here, you are learning, right? It's not that you should be getting discouraged. And others, you may think of hanging. I've seen students who they're hanging it now. They are taking ropes and you hang yourself, right? It's nothing. This is nothing, right? You are learning, right? And moreover, if you have what you have done there, if you wrote an assignment, you are 60, you are 70 from your 3%. You are 70 now. Go there. Now, I'm trying to encourage you that I will not count that, but do that as an assignment. And that assignment is what I will count. Right? To good result. What have I said? Yeah, write that. My friend, have you understood what I'm saying? What am I saying? Yes, write that as an assignment. And I'm not recording in my book. I will record what you are going to get. All right? Eh? I will record so I will record what you are going to get with the assignment that you wrote, right? Because if you have done, but you have to do that as an assignment. All right? Yeah, a good teacher. Right? Is not. I'm not taking that. I'm not counting that. Huh? No, it's up because you have got plenty of things. You have got plenty of work to do. It's up to you to delay. It's up to you to do it fast. All right? It's up to you to delay. It's up to you to what? Now, what you have to do is when you write, all right? When you write, I think for the papers, I think I will give you papers where to write. All right? I'll give you the same papers. But when you write, this one, it's not. You are not supposed to post it on portal. Give me physical. All right? I don't want you to just copy, but understand. All right? So what does that mean? What it means is, I will next week, the same time. All right? I think next week I will be in Blantyre. I will not be here. I will inform you on the group. I will be doing something else. So next week, the same time like this time, I would urge you to make the discussions and you write. All right? Clear? All right. Now let's proceed from where we stopped. Yeah, brother. Let's just carry that one. Now we are going to part 2 of quantitative techniques. So you have to be very fast again. Part 2 quantitative techniques. We have gone away from standard deviation. We have gone away from standard deviation. We want to go to another area now. Oh yeah, I'll leave it there. It's enough. It's fine. Good. Good. All right. We have run away from standard deviation. We are now going to another area. Is it possible that you go get these markers from the reception? At the reception, whosoever you are going to find at the reception, I think that'd be much better. We are starting. Skilled. I'm starting on skilled. Skilled. You have your books in your phones, right? All right. This is QT. Quantitative techniques. Skilled. Key skillness. All right. So when we look at skillness, we are looking at the degree of skillness. We are looking at the degree of distribution. In other words, skillness describes the degree of distribution. That's skillness. Describes the degree of distribution right? So we have already looked at this skewness in form of 3. We have looked at this skewness in form of 3 dimensions. So we have looked at it in terms of positively skewed, all right? We have looked at it in terms of negatively skewed, skewness, then normal skewness, then another one is what? Another one? Positive skewness. 84. All right. Now, when we look at negative skewed, let me just put the word skewed here, not skewness. Skewed. We talk about negative skewed. Negative skewed is when you have something like this. Positive. Positive, right? This one. This one is negative skewed, right? This is negative skewed. I actually said where you have got negative skewed, it means that the exam was it was easy. A lot of them have passed, right? So it means that a lot of them have passed here. This is an easy exam. Easy exam. A lot of students have what? They have done what? Well. All right? What is making us saying that a lot of them have done well? Simply because if you look at what is happening here, the numbers here, 0, 20, 30, 40, all right, 30, 60, let's take 20, 20, 40, 60, 80, 100. So a lot of them, they are here. That's why I'm saying that a lot of them have passed. This, a lot are here. A lot are here. Hey, that. Very little, very small, a small group number of numbers they are here. A lot of have passed. You understand? A lot have passed. That's why they are here. The marks are between 80 and 100 here. That's why we call that one is a negatively skewed. Negatively skewed is telling us that the exam was very easy. Because the exam, it pulled all the students from here. It had to take them, a lot of them, they are there. Can we stop looking at our papers, please? Let's stop looking at our papers. All right, so what I say, a lot of them, they are here. Right? That is what is called negatively skewed. A lot are there. Now, when you look at negatively skewed, right? the tail is being pulled to the negative direction. That this tail has been pulled to a negative direction. That's why it is negatively skewed. The tail has been pulled to this side, negatively skewed. What does that mean? There are two things that you have to look into that. When you are looking at this situation in skewedness, you consider three things. What are the three major things that you consider in skewedness? Three major aspects. Three major aspects to consider. Three major aspects to consider in skewedness. In skewness. There are three major aspects to consider in skewness. What are these? One, mean. You consider mean. Another one, mode. Another one, median. When you look at that, you consider these three things: mean, mode, median. Now, what is mean? The mean is the one that you are talking about. This one. This is mean. The mean is that. All right? In other words, mean here, what it means is you look at, you sum x divided by n. That's the mean, right? Remember, you had to add in numbers and divide by how many they are, right? You remember that? If you are given a set of numbers 5, 4, 1, 1, 2, 0, find mean. You had to sum all the x's divided by n. That is your mean. Right? Where here you had to take this plus this plus this plus this plus this plus that. 13. 13 divided by how many numbers are there? 1, 2, 3, 4, 5, 6. Divided by 6. Then this gives you 2 and 1 over 6. This is your mean. That's what we are looking at. Now, I'm not looking at how we should solve this, but I'm saying that there are three things. In terms of mode, a mode or number, what is a mode? What is a mode? What is a mode? A number that is appearing many times, frequently. Very good. So it is appearing many times. Very good. Many times. So a mode is a number that is appearing many times. Many times. In other words, a mode is a number with the highest frequency. You look at the frequency, find out which number has got highest frequency. That is your mode. If you look at median, what is a median? A median is a middle what? Number. If there are numbers, median is the middle number. If there are 1, 2, 3, 4, 5, median is this one. Alright? But if there are 1, 2, 3, 4, median. But now, for you to understand this median, if you want median, you have to arrange the numbers in order. Arrange them in either ascending or descending what? The problem is you are failing to arrange numbers in order. You are failing to understand that this is number. You have, for example, 5, 2, 1, 5, 4, 1, 4, 2, 4. Right? Arrange them in order. So the first one is what? 1. Another one? 1. Another one, 2. Another one, 4. Another one, 2. 2. Another one, 4. Another one, 4. Another one, 4. Another one, 5. Another one, 5. You arrange them in order. Then you count. Oh, this and this. And this and this. This and this. This and this. Therefore, the median is this one. Median is 4. So the median is this number which is at the middle here. This is your median. So we are looking at this being the median because it is at the middle. Assuming that you have arranged them in order and there are 4 numbers, 1, 2, 3, 4. So the median is this and this. So what do you do to these ones? You add them, divide by 2. Clear? Yeah. But if you have arranged them in order, 1, 2, 3, 4, 5. This and that. You have done this and that. The median is this one. But if there are 4 of them, this and that. So we have got these 2 here. You add them together, divide by 2. But what I'm trying to mean here is, we are looking at this negative rescue. In other words, always median is not affected by any stream numbers. Median will be median. Look at this one. Median will be median. Middle number is middle number. Middle number is not affected. What is affected there? What is affected is mean and mode. Median will be median. All right. I've forgotten my ruler. Next time when I come, I want to take my ruler. Now, what does that mean? Negative rescued here. There will be one line which is a median here. This is your median. All right? Positively skewed, there will be a median. Normal distribution, there will be a median. But what is different to say that this is negative skewed and positive skewed? It is mean and what? Mode. For example, in a situation where it is negatively skewed, here, mean is less than mode is less than median. Where mean is less than mode is less than median. No. What mean is less than median is less than mode. It is now negatively skewed. So the situation is when mean is less than median is less than mode, which means this median is going to be at the center here. Median is going to be at the center. That's why median is here. Median will be there. Mean, it will be less. So if it is less, our mean will be here. Our mean will be here. Our mean will be here. This is our mean here. X bar. Mean is less than median. In other words, median is greater. That's why median is here. Median is greater. Median will be here. This is our median. The last one here is going to be what? Mode. Mode is going to be here. What does that mean? What does that mean? If I give you a set of data, if you are given a set of data, when you calculate mean, you discover that this mean has got a small value, but the median is a greater value, and you calculate mode, you find that mode is greater than this and this. That is negatively skewed. Because these are numbers here. Mean 3. Mode, median 5. Mode 7. If mean is 3, mode 8, median 20, then it is negatively skewed. When you calculate this and you find that mean, see, mode, you rate them. When mean is less than mode, or when mean is less than median, less than mode, that is negatively skewed. What about positive skewed? Positive skewed will be this scenario here. Positive skewed. What does that mean? 0, 20, 40, 60, 80, 100%. It means a lot of students have scored 20%, they are here. A lot of them, they have scored 20%, they are here. This is what is called positive skewed. So this is what is called positive skewed. Positive skewed, what does that mean? The exam was difficult. A lot have failed. Right? Now, what is it? If you are to relate this. In this context, the one that will come here first is going to be mode. So here is going to be mode here. Mode, median will be still at the middle here. Mode, and mean will be at the end, the far end here. Mean is going to be at the far end. Now, in this context, when mode is less than median, is less than mean, that is positive skewed. Mode is here. Here, mode is at the end. Median will be still at the middle, like here. Mean is here. But our mean here was here. What does that mean? This means that is positive what? Skew. When you calculate, if I give you a problem and you calculate, you find the mode is greater. How? When the mode is a smaller number, median is a little bit bigger, mean is the greatest number of all, that exam is positively skewed. That is a very difficult exam. You calculate based on this, mean, mode, and median, for you to understand the skewedness. Let me go to this one, which we call the normal distribution. normal distribution. The normal distribution, now it is in this category here. Normally distributed. This is normal distribution, where mean is there, mode is there, median is there. When mean, mode, median have got the very same value, mean 20, median 20, mode 20, that is a normal distribution. It means that the exam was 50-50. So it wasn't difficult, it wasn't easy, but that is 50-50. Now, in that context here, is where mean here, mode there, median there. So, mean, mode, median. Mean, mode, median. Oh, that is what is called normal distribution. In other words, the normal distribution, when mean is equal to mode, here, mean is equal to mode is equal to median, that is a normal distribution. That is what is called a normal distribution. Sometimes normal distribution is referred to be as a symmetrical distribution. Sometimes normal distribution, this is normal distribution here. Normal distribution curve. Sometimes normal distribution curve, it is referred to as symmetrical. Symmetrical, why symmetrical? It is half-half. It is sometimes referred to as symmetrical. Symmetrical. Why symmetrical? Because it is half-half. Let me now go to another concept, which is sometimes the issue on the relationship between mean, mode, and median. All right, let's look at this concept that describes the relationship that is satisfied mean, mode, and median. So when I give you an exam and you find that you have failed, and I come to class and try to find out from you what type of skilledness is this one, I don't want you to fail. You tell me it is positive skilled, it is negative skilled, it is normal distribution, or it is asymmetrical, or it's not like that. I want you to be explaining it like in those contexts. All right. Now let's look at the relationship between mean, mode, median. And this relationship now it is taking us to what is called Pearson coefficient of skilledness. It was this guy, Pearson, one who discovered this relationship between mean, mode, median. and we call this theory as the Pearson coefficient of skewedness. Let's now start in Pearson coefficient skewedness. Pearson now. Do we have someone here by the name of Pearson? Do we have Pearson here? Who is Pearson? Huh? Oh no, Pearson. Ah, good. So that one we call Pearson coefficient of skewedness. So Pearson coefficient of skewedness. Aha. Skewedness. Pearson. Right, Pearson coefficient skewedness, it describes the relationship that satisfies the mean, mode, and median. Satisfies. Relationship between, not between, among mean, mode, and median. All right. In general, when you take mean minus mode, when you get mean, subtract mode, that is just an equivalent to 3 bracket mean minus median. I.e., I will tell you, don't worry. I will tell you. Let me explain now. Mean minus mode is equivalent. Now I'm answering you. Is equivalent to 3 bracket times mean minus median. What does that mean? Something that is equivalent is not the same. All right? It's just close to that. All right? Like 3.4 is equivalent to 3.421. They are not the same, but it's just more or less like. All right? So when you calculate your mean, you calculate your mean from the sum. You minus a mode. A mode is a number that is appearing mostly, right? When you subtract the two and go the other side, find mean, you subtract the median, the two answers you multiply by 3. What you get here and what you are going to get here, they will be just equivalent. They're not going to be the same. All right? So for example, let's take an example. Let's take an example. 5, 4, 3, 1, 5, 2. Let's find mean, mode, median. Let's find mean, mode, median. All right? What is our mean? Mean is equal to, you add this, right? 9, 12, 13, 18, 20, right? So it is 20 divided by 6, which is 3.3. All right, let's put it like this. Let's find the mode. What is our mode? Our mode is number which is appearing most is what? 5. Let's find our median. Middle number. Arrange them in what? Order. So it's going to be what? 1, 2, 3, 4, 5, 5. This was right. Add the 2. 7. 7 divided by 2. 3 point what? 5. Now let's use this. Oh, this is 3.5. Eh? Let's use the mean, mode, median to come up with the where here. What is our mean from there? 3.3. 3.3 minus mode 5. Can you subtract the 2? Negative, yeah. Negative 1.7. Let's go to the other side. 3 times, what is your mean? 3.3 minus median 3 point what? 3.5. You do the inside first. What is 3.3 minus 3.5? Negative. Negative what? 3.3 minus 3.5? Negative 0.2. All right? Right? Multiply by 3. Negative 0.6. Negative 0.6. Negative 1.7. Are they the same? Huh? But they are just what? Equivalent. They are not the same. They are just equivalent. That's what we are trying to find out from me. That's how it will not be the same, but they will just be equivalent. According to Pearson. Pearson is the one who actually is telling us that. But now, what is this Pearson trying to say? Pearson coefficient of skewedness is describing something like this. Pearson coefficient of skewedness, it is describing as something like this. Is saying Pearson coefficient. Pearson coefficient of skewness is saying something like this. Is saying mean minus mode. He's taking the first part here. Right? Huh? Mean minus mode divided by standard what? Standard deviation. When you divide by the standard deviation, right, it will be just equivalent to, this will be just equivalent to, you take 3 bracket, Pearson again is saying 3 bracket, mean minus median divided by standard deviation. sigma. By sigma, that's standard deviation. This is what is called sigma, standard deviation. All right. What is actually saying, if mean is greater than, I think we have looked at that one. Pearson generally looks at the value. In other words, if I ask you a problem and I say, can you work out using Pearson? If you can use this formula, the answer will not be very different. They're not going to be very different. They'll be just equivalent. I'll mark. But that's what I mean, it will be the same. You can find the mean, mode, and you can work out standard deviation. Mean minus median times 3 divided by standard deviation. What you are getting from this one is still is Pearson coefficient. If you have forgotten this formula, why can't you use that formula? If you have forgotten this one, why can't you use this formula here? When you use the two, provided you have to know what is mean. But if you don't know how to calculate mean, it's a problem. You need to go, what is mode? And then finally, you need to know what is standard deviation. How do you calculate the standard deviation? Sigma. The moment if you look at this, what you are trying to do it here, and what you are trying to do it in the other side, when you marry the two, at least can give you a very good picture of what you want. So, those are two different formulas. Yeah, those are two different formulas. This one is but where you are going to reach, you are going to be, the answer will not be different, but it will be just close to. Okay, it means on exam you can just choose this part. Yeah, in exam, if I ask you calculate, I can give you data, right? I can give you data 5, 4, 1, 2, 1, 3, and I say use Pearson coefficient. Calculate the coefficient. Generally, we'll look at what we are trying to mean here. We'll look at an information and then you see how we can look at that. Skewedness lies between 3 and -3. Your answer, skewedness, the answer, they apply between 3 and -3. So skewedness lies between 3 and -3. What does that mean? Your answer, they have to be bounded. If you find that your answer is 4, something's wrong with you. You are mad. Something, even you don't write that answer. Because skewedness lies between 3 and negative what? In other words, if I am to draw a number line, what I'm trying to say here is this. If I have to draw a number line here, I've drawn this is my number line. If I have to draw a number line, this is it. Assume -4, -3, -2, -1, 0, 1, 2, 3, 4, skewedness answer, they have to be between here and here. Your answer have to be within here. If you tell me the answer is within this, yeah, at least. The answers have to be between -3, anything in between here. But outside this cannot be accepted. Outside this boundary cannot be accepted. Your answers have to be in what? Between. If you tell me the answer is 4 or 3.1, you have missed. Because 3.1, you have gone out there. It has to be between -3. Tell me about -3, -2, -1, 0 or 0.5 or 1.2 or 2. Tell me something in between here. Tell me something in between here. You be my friend. You be my friend. But if you tell me something which is outside, like this, like there, then you are out of the context. All right? If you look at you can check for, there are several distribution, there are several things there, but let's look at an example. Open your whatsoever. Page 85. Let's just go quickly that example. I want to finish off that example. Are you there? Yes, an electric fuses normally rated at 30 amperes, 30 amps, are tested by passing a gradually increasing electric current through them and recording the current as X amperes at which they blow. The results of this test on a sample of 125 such fuses are shown in the following table. All right, so they're talking about an electric fuse. You know what a fuse? You did the physics. Yeah, you did the physics. You know what a fuse? Hey, when electricity is passing through that fuse, someone is doing an experiment. But normally rated at 30 amps. You know what these fuses, they are in amps, right? Huh? Yes. My friend from Kenya. Oh, you are from Kenya? Zimbabwe. In Zimbabwe, you did the physics, right? You know the amps. What are amps?
It's more like power.
Power. It goes together with the volts, electricity, right? Yeah. So this experiment here, that's very good. I thought maybe in Zimbabwe you have never done physics. Here in Malawi you do physics, you guys, right? Our friends, they are much. They know these things. All right, maybe. So maybe it might be because we are coming from different schools. You are coming from CTSS, where I don't have. Provided is school, right? School is school, right? Yeah, school is school. Whether you are leaning on under the tree, provided you learn amps, right? All right. So this experiment, they are trying to find out, right? They are trying to find out if they increase the current. The moment they increase the current, what is happening to these fuses? Sometimes the more when they increase, they discover that these fuses will blow. cut off, right? So they are trying to record. So what they are saying is, when the amps is between 25 to 28, they counted 6 fuses